What is the water footprint of beef? To start, we need to define a water footprint. A water footprint is the amount of water used to produce a given product. For beef, water footprints are often defined as gallons of water required per pound of beef. It is important to note that the relative importance of water use is highly dependent on location because, unlike other environmental issues, like greenhouse gas emissions, water use and access are highly regionalized issues. For example, in the southern high plains, approximately 30% of cropland is irrigated with water from the Ogallala Aquifer. In some, but not all locations, water is being drawn from that aquifer at a faster rate than it is being recharged. Clearly, the use of a unit of water in such an area would be viewed and valued differently than a unit of water used in an area primarily that relies on precipitation for its agricultural production. As a result, one must be cautious about generalizing water footprints of beef or any other product on a national scale. In the scientific literature, one can find estimates for the water footprint of beef ranging from a little over 300 to up to almost 24,000 gallons of water used per pound of boneless beef. So why is this range so large? The range depends upon the methodology and assumptions made by researchers, such as the types of water that are considered in the footprint analysis. You may wonder what is meant by types of water. These are classifications of different consumptive water uses. There are three main types of water that can be considered in a water footprint, and those are blue, green, and gray water. Blue water includes all surface and irrigation water sources. Green water is the water from precipitation that is stored in soil and is available for evaporation and transpiration by plants. Gray water is the fresh water required to dilute out pollutants to meet water quality standards. The inclusion or exclusion of green water in water footprint analyses of beef explains much of the range of reported beef water footprints in the scientific literature. Accounting for green water in the water footprint of beef means considering all the precipitation water that is required to grow the feed used to meet the nutritional requirements of cattle. This can include the precipitation that is used to grow grain crops like corn and forages. Forages include planted and managed crops like alfalfa, which may be a part of multi-year crop rotations. Forages would also include plants growing in permanent pastures and rangelands. To demonstrate the impact of including or excluding green water in the water footprint of beef, we can examine the work of Rotz and others published in 2013. Their research evaluated the water required per pound of body weight of cattle sold at the U.S. Meat Animal Research Center in Nebraska. When precipitation was included in the analysis, the researchers observed that the water footprint of beef was 2,557 gallons per pound of body weight. Without precipitation, the water footprint was 334 gallons per pound of body weight. Not including precipitation decreased the water footprint of beef by 87%. The researchers also dug deeper to understand what parts of the beef production system were using the most water. The U.S. Meat Animal Research Center is a USDA facility in Clay Center, Nebraska. It is unique because the majority of the cattle feeds are grown and harvested at the center. Additionally, the facility has both a spring and a fall calving cow herd and a feedlot where the cattle are finished before being shipped from the center to be harvested. Because multiple parts of the beef production chain were present at the center, the researchers broke out the water footprint into the crop farm, the cow-calf operation, and the feedlot. As can be seen in the figure, when precipitation water was excluded from their analysis, water use declined in each part of the beef production chain. Another interesting observation is that the largest water-using segment for the beef production chain depended upon if precipitation water was included or not. For example, when precipitation water was included, the cow-calf operation contributed the greatest proportion of the total water footprint, representing 76%. However, if precipitation water was excluded from the analysis, the crop farm became the largest proportion of the water footprint, accounting for 64% of the total water footprint. Why the difference? The cow-calf phase of beef production is extensive, meaning animals are managed outside and are primarily meeting their calorie and nutrient requirements by grazing. The number of acres required to support a cow and her calf varies considerably across the country, from in some cases less than 2 acres per cow-calf pair in the eastern U.S. to more than 100 acres in parts of the arid western U.S. Of course, precipitation varies considerably in the U.S. as well, but as a specific example of Rotz and others demonstrates, including precipitation water can greatly increase the estimated water use of the cow-calf phase and the total beef water footprint. While beef water footprint analyses can vary depending upon the inclusion of precipitation water, water used for irrigation is nearly always included in a beef water footprint. Irrigation is used for feed production in many parts of the U.S. and is also used for cattle pastures in some cases. Irrigation water can come from either groundwater or surface water, both of which are considered blue water sources. Adopting improved irrigation technology that can improve the water use efficiency by crops is one example of an opportunity to reduce the water footprint of beef. Other management and technology changes that target feed production can also have an effect on the water footprint of beef. This is because feed production represents about 95% of the total water footprint of beef when considering the entire beef production chain. The direct consumption of drinking water by cattle represents only about 1% of the beef water footprint. Other opportunities to reduce the water footprint of beef include improving the production efficiency of beef and harvesting rainwater at retail locations that sell beef products. Production efficiency refers to decreasing inputs required per unit of output. Specifically, further improving the conversion of feed into body weight gain of cattle could reduce the water footprint of beef. Harvesting rainwater means developing a system to capture rainwater that runs off impervious surfaces such as roofs and parking lots. Depending on the design of such a system, harvested rainwater can then be used for irrigation or even for non-potable water uses like flushing toilets within a building. Recycling water in such a way can reduce water used from municipality sources. This concept of harvesting rainwater may seem far away from beef production. However, it is important to consider water uses in the beef production chain that happen after the ranch or the feedlot. In summary, the water footprint of beef can vary considerably based upon the methodology chosen by the practitioner of the analysis. Peer-reviewed U.S. water footprints for beef have estimated the water footprint of beef at 317, 441, and 808 gallons of water per pound of boneless beef when precipitation water was not accounted for in the calculations. Part of the range in these three estimates is due to the level of irrigation assumed during the production of cattle feed. Including green or precipitation water in the water footprint of beef can dramatically increase it above these listed estimates. There are opportunities to reduce the water footprint of beef throughout the production chain, but most water is used to produce the feed for cattle.